Hello, this is LeetCode 494, target sum. We have an array nums and a integer target, and we're going to make an expression by putting either plus or minus before each integer, and then put them all together into an expression. So basically, we're going to take all the numbers in nums, start with 0, and you either add or subtract each number. If your result is target, that's one way to reach target. You want the number of ways to reach target. You can pause and read it if you're not sure what I mean. But it's a basic backtrack problem, at least first approach. I'm going to say n is the length of nums, the number of nums. Ways is 0. I want to return ways, so I'm going to backtrack. Basically, you start at 0. And for every number, you either add it or subtract it. So from 0, if our number is 1, we can get to positive 1 or negative 1. Backtracking checks every possible path until you either reach the end or your target. Well, you have to reach the end in this problem, but there's lots of ways to do backtracking. So I'm going to write out that basic backtrack method right now. It's going to take index and current. And let me write this down just so it's clear. I want index to be the index in nums. So for the first example, this 1, it's index 2. It's also the, not num, well, it is num of num, the count of nums, of numbers that have been passed so far. So if we're at this third one, which is index 2, we've also passed 2 other numbers, which are also 1s in this problem, but that's how this example works. And it's a little clearer later, but that's index. Current is current sum. The current sum of all numbers passed so far. So I'll use those definitions for this backtrack method. Basically, you want to find the current number, which is just nums index, and then you want to do 2 things. You can either add it or subtract it. If you add it, you want to call backtrack again with an index 1 more, because we passed the num, and want to go to the next num in nums with current plus num. But you also want to subtract the num. So in every node or every step of backtracking, there's 2 possibilities. You add the number or subtract the number. That's why every time we call backtrack, we call it again 2 more times. Of course, this is going forever unless we stop it. And we want to stop it when the index is out of bounds, which is also when we've reached every single number in nums and either added or subtracted it. So if index is equal to n, we're going to stop. But that's where we check what the problem's looking for. Did we reach target? If current is equal to target, then ways, that's one way to reach target. So ways plus equals 1. And then we'll return, because we don't want to keep going once we reach index n, because there are no more nums to add or subtract. This is the basic way to solve the problem. I think it should basically work. I just want to add one thing, non-local ways. Otherwise Python will say, ways, a new local variable, not this ways, but actually I do want the global ways that I've defined before. And we'll see if this works for my test cases. Plus equals 1. Oh, one important part of backtracking, call your backtrack function. We need to actually call the function, and we need to do it from the very start. From the very start is index 0, which is also saying we've passed 0 numbers. That makes sense. And the current sum when we haven't added or subtracted any numbers yet, of course, that's 0. So this should work for my test cases. Yeah, and that works. And that's a pretty good explanation of backtracking if you haven't seen it before. I also want to, let's do one more. Let's do 10, 20, 30, and let's try to get to 0. That should work for all the test cases. But it's not going to work for the longer arrays nums, because there's a lot of repetition, which is a big clue that you want to use memoization. The backtracking is good. I'll keep this definition, but it's not going to work for a longer problem. And that's because there's a lot of branches. If every number you add, you can either add it or subtract it. I'll start with example 1, which is all ones. The first example. First test case, I mean. That's fine. One case, two cases. If you get +1 + 1, you get 2. -1 -1, -2. +1 -1 is 0. And -1 + 1 is also 0. We're going to have 2 to the n calls at the last step, which is a very large number. And we can make it much faster by consolidating these. And you might see it right here. We're going to consolidate these two cases right here because they're actually the same case. There's basically one way to reach 1 after the first number. If I have like columns, the columns are basically I. When I is 0, I've added 0 numbers, so I'm at 0. When I've added 1 number, I could be at +1 or -1. And here, this third column is when I've added 2 numbers so far. I'm at index 2. There's only one way to get to +1 in index 1. That's adding the 1. There's only one way to get to -1. Subtract the 1. And if we say that we start at 0 and have added 0 numbers, then let's say there's only one way to be there. There's only one way to start. There's only one way to get to +2. There's only one way to get to -2 for index 2. But there are 2 ways to get to a current total of 0. So I'm going to combine them right now. To get to 0, there are 2 ways. Oops, I made a small typo. This is a 1. That's fine. I could take this path +1 -1, or this path -1 +1. They'll both get me to 0 at index 2. So there are 2 ways to get there. I'm going to make a new memo. It's going to be a 2D memo where the first index is index, the second index is current, and then the value is ways. Ways is the number of paths to reach current, the current sum, at index. Or after index numbers. So this will be really cool if we can get this to work. We're not going to have ways anymore because we're going to have many, many ways. We're going to have a whole 2D memo full of ways. So that's not going to work. Here's what I want to do. Let's look at one example. Let's look at getting to +1 after 3 numbers. So when I is 3, how many ways are there to get to a total sum, a current sum, of +1? If you look, there's 3 paths. you can go +1, +1, +1, +1, -1, +1, -1, +1, or -1, +1, +1. So there should be 3 paths. This is the answer we expect to get. How do you find it? Well, there's 2 ways to get to +1 in index 3. We can go from +2 in index 2 and subtract 1, or 0 in index 2 and add 1. And this again assumes all the numbers are 1, which is kind of a easier test case, but a little confusing. So the reason why this is a 3, there are 2 ways to get there, but there's only one way to reach 2 at index 2. As this number says, there are 2 ways to reach 0 at index 2. So this result, the 3, is 1 plus 2. So that's what backtrack is going to do. We're going to do this kind of backwards, but for every step, we're going to look at memo. I'm going to call this, yeah, that's fine, memo of the previous index and then whatever the current value was. We could add the current number. So, actually I have this backwards. Memo index is our current state. Let's say it's +2 at index 2. We know we could subtract 1. So, memo index +1 with a with a current sum plus our current number, which we'll call num, is increased by ways. And we can also subtract. So therefore, if we subtract nums, we also have however many ways we have to get to memo index current, which is ways. I already wrote that right here, but yeah. However many ways there are to reach this number, there'll be that many ways to reach this number, which is current sum minus num, and also current sum plus num. So how do we make this work? We're going to do this n plus 1 times. Right now, n is 5 in this example. We need to do it 6 times actually, because we're going to do it for having 0 numbers, 1 number, 2 numbers, 3 numbers, 4 numbers, and 5 numbers. We need to add all 5 numbers to see if we reach target or not. So we're going to do this in range of n plus 1. Sorry, that's not right. We are going to use n because once we've added, once we've done 4, 4 will fill in memo of 5, and then we'll be done. We don't need to do memo of 6 because there aren't 6 numbers. So we actually only need to go up to 4 because that actually sets memo of 5, and that's what we want. And then we need to find num. The current num is just num's index. I think we had something like that before. I think I made the same mistake before too, but that's okay. And we're going to find current and ways. Current and ways are all the keys and values in memo's index for current ways in memo index. Memo index, I'm going to make a default dict. So to make this work nicely, I'm going to use a default dict. Not a default dict, sorry. An array of default dicts. And here's wrong with the n+1. Because I need a memo for having 0 numbers up through including 5. So I need 6 default dicts. And a default dict, in case you don't know, is a dict or a hash map with a default value. Here's a little reading if you want to take it out. But this function int returns 0 if there's no arguments. So basically, every value, if I don't set it ahead of time with a key, will default to 0. If you don't want to use default dict, you can pretty easily just check if the key exists and then set it to default, or using JavaScript where it doesn't have this. Either of these ways will work, but I'm going to use default dict to save me a little bit of time. So basically, if I index into memo with index and current, and that key has not been set yet, it'll become 0 automatically, which is very nice. And to make sure this works, I want to make current the key and ways the value, not key and value, keys and values in memo index. So I'm going to use .items, which would be .entries or object.entries in JavaScript. And then we have to indent one more time to make the Python work. And that should just about be the correct setup. We have to set the first value in memo to be 1. Otherwise, they'll all just be adding 0 every time. And the first value is 1, because like we were saying before, when you first start out, there's only one way to start out, by adding 0 numbers together. You start out with one path, and it splits into 2. So hopefully this makes sense. But yeah, when you've added no numbers, there's only one way to get there. And when we return, we want the final ways, which is memo n, when you've added all n numbers in nums, and target. So this will be the number of ways to reach target after n numbers, the number of ways to reach our current sum of target after index is the number of numbers we passed. That's exactly what we want. So this should work. And it should save time because we've consolidated from 2 to the n down to a much smaller number of possibilities. Same problem before. We need to, is this the same problem? Nums. Yes, nums instead of nums, and that should probably work. So now that we're done with this video, yes, we did it. Great job. I'll be going. Have a great day, and good luck with similar problems.